Hi students, welcome to this course, PLC Automation, an Introduction to Programmable Logic Controller. I am Professor Yao. PLC conversions between decimal and BCD. The keywords: the inverse conversion, a typical PLC application program requiring number conversions. Many PLCs include these functions for converting BCD numbers to binary for use by the CPU. They also can contain the inverse conversion binary to BCD. Figure 13.8 is a typical PLC application program requiring number conversions. It illustrates in block diagram form how the conversions are accomplished. The mathematical manipulation in the middle block can take any form. This picture shows block diagram of a PLC BCD to binary conversion program. Figure 13.9 shows the layout of a typical BCD to binary conversion function, which is usually used for input data conversions. It converts the BCD value found in the source register to a binary number in the destination register for the PLC CPU use. This picture shows the program of BCD to binary conversion function. When the function's input line is energized, value in the source register are converted from BCD to binary. The resulting number is put into the destination register. Typically, the coil comes on only if one of the BCD register digits exceeds 9 during mathematical conversion. Figure 13.10 shows how the reverse of the conversion in figure 13.9 is accomplished. A binary value in the source is converted to a BCD value in the destination. This function's primary use is for feeding and output display. Typically, for this function, the coil comes on only if the binary value exceeds 9999 in decimal during operation. This picture shows the binary to BCD conversion function. Octal and hexadecimal numbering systems. The keywords: the octal code and the hexadecimal, shortened to hex, a base of 8, a base of 16, hex to decimal equivalent, a table comparing value, repetitive division. Two other number codes often encountered in dealing with PLC and computers are the octal code and the hexadecimal. Hexadecimal is normally shortened to hex. The octal code uses a base of 8, and the hex uses a base of 16. In the computer's numbers, if the computer's numbers are 3 bits long, it is in octal numbering system. 3 bits can count up to 7 as the maximum and start over at 8. If 4 bits are used for each number, the numbering system is in hex. 4 bits can count up to 15 and then start over at 16. Figure 13.11 shows the comparison of octal and hex to decimal equivalents. Figure 13.12 gives a table comparing values for decimal numbers with their octal equivalents and the binary for reference. When we reach 8, octal starts over and the 1 goes in the slot to the left. This figure shows decimal to octal and hex system comparison. Decimal, octal, and hex. This picture shows octal code table. Figure 13.13 shows some typical octal to decimal conversion. And figure 13.14 illustrates some decimal to octal conversions. The hex system uses 4 bits per number compared to octal's 3. Therefore, hex is base 16. Since we must count beyond 9 in a single column, we use sequential letters of the alphabet for numbers 10 and through 15. The hex system is shown in figure 13.15. This picture shows octal to decimal conversion. This picture shows decimal to octal conversion. This picture shows decimal hex binary conversion. As you can see, the hex base counts from 0 to 9 and then continue with the A, B, C, D, E, F. Figure 13.16 shows how hex numbers are converted to decimal. The conversion uses straightforward multiplication, as does the octal to decimal conversion. The conversion of decimal to hex is a little more involved than hex to decimal. We use repetitive division similar to that used for decimal to octal conversions, as shown in figure 13.17. Hex number, conversion procedure, decimal result. This shows decimal to hex conversion. Homework: handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.